Hi guys, Omores here. Today we're looking at how to boot from NVMe SSDs on systems that have absolutely no idea what NVMe even is. We're talking about older PCs here, pretty much anything released before around 2015. Now we can even do it on a Pentium II if we really want to, although doing it on an i7 system with a 4th gen Intel motherboard makes a lot more sense. To pull this off, the secret ingredient is an NVMe BIOS Option ROM, a clever bootloader created by Worm, who's also a founding member of the KittenLabs project. For the rest of the video, I'll simply call it KittenLabs Option ROM because it's a lot easier to say. If you haven't heard of KittenLabs before, definitely check them out. They're working on some seriously awesome low-level hardware and firmware projects. So if we really want to connect NVMe SSDs to older systems, this is actually the easy part. All we need is a free PCI Express slot and an adapter like this, an M.2 or NGFF to PCI Express adapter. NGFF technically means next generation form factor, but nobody really calls it that anymore. Today it's just M.2, and these slots were actually standardized a couple of years after the NVMe protocol was first published in 2011. Anyway, it took a few more years before NVMe became a thing. In fact, some early PCI Express SSDs preferred the old AACI protocol, just like regular SATA drives did and still do, because it was simply more software compatible. Still, NVMe took over pretty fast because it was specifically designed for SSDs and it can handle way more operations at a time, something AACI can't do. That's mostly because AACI was originally designed for mechanical drives, where the read-write heads can only be physically in one location at a time. So it didn't make sense to have 65,000 command queues like NVMe does. Now, to boot from an NVMe SSD, the BIOS first has to figure out that the drive was even there. To an older BIOS designed before NVMe even existed, our SSD looks just like another device on the PCI bus, nothing special about it. It's exactly the same reason an older OS like Windows 2K initially sees it as an unknown PCI device. Without an NVMe driver, it has no idea what it's looking at. But the moment we install the driver, Windows recognizes the controller and the SSD comes to life. Still, that doesn't make it a boot device because the NVMe controller has to be initialized before Windows or DOS or any other OS ever starts. That's why before the BIOS lists the available boot devices, it checks whether any PCI card wants to execute some extra low-level code called an Option ROM. That's also why some of the earliest NVMe drives, like the Samsung 950 Pro, shipped with their own Option ROM, whose job was to scan the PCI bus, find and initialize the drive, then present it as a standard hard disk using something called INT13H, a BIOS service that's been used to access disks since the original IBM PC. As I've showed you here, this is DOS 3.3 from 1987, checking an NVMe drive properly formatted and exposed via INT13H. Alright, now let's talk about how to actually use this custom NVMe boot ROM. Well, until recently, this thing had to be deployed like a traditional Option ROM, typically by flashing it onto the boot ROM of a network card. The downside is that flashing the ROM onto most network cards can be a bit of a pain, but I'll show you how to do it in a moment. The good news is that since the latest release, you don't have to flash anything if you don't want to, because now you can deploy this boot ROM from almost anything, a USB drive, floppy disk, CD-ROM, or even another hard drive. The easiest way is, of course, from USB. Just download NVMe boot.usb file and tell Rufus to write it to a USB drive. That's literally it. If you select the USB drive as the boot drive, it will summon the NVMe SSD in a blink. Just don't try it on a system that already has native NVMe support, because if the drive gets initialized first by the BIOS, it's not gonna work. Now let me show you how I flashed my Intel network card. On GitHub, you'll find a list of ROM files, but the names don't tell you much because they're mostly based on the target hardware IDs. For example, 8086 is Intel's vendor ID, while 1209 is the device ID for the Intel Pro 100 controller. So 8086 1209 ROM should work with a Pro 100 card, which is exactly what I tried first. Actually, my Pro 100 card hardware ID was 1229, so I modified the ROM file accordingly. Unfortunately, Flash ROM couldn't write anything to the flash chip, and Intel's own utilities won't let you flash just any ROM onto the card. So instead, I modified the ROM again by replacing the hardware ID with one from an Intel Pro 1000 card, since those are much better supported by Flash ROM. Then I used the DOS version of Flash ROM to write it. The ROM itself was only about 25 kilobytes, but the flash chip was 128K, so I had to pad the file by filling the remaining space with dummy bytes. If you're interested in the details, I have posted the full write-up on my Patreon. Now the best part is that it actually works, and now I can boot directly from an NVMe SSD using my Intel network card, while still having a fully functional gigabit Ethernet adapter if I need one. So here is the KittenLabs NVMe boot option in action on my Pentium II 350 system. The NVMe drive is connected through the PCI to PCI Express adapter I showed you before and is detected without any issue. The problem though is how Windows 98 accesses the drive through INT13H. While the Option ROM does its job loading the boot sector and starting Windows 98, the system will eventually freeze or throw a Windows protection error. This is a known issue with Windows 9X, but other than that, the INT13H implementation works fine in DOS and anything based on Windows NT, including Windows NT 4.0, which, by the way, does have a proper NVMe driver. Of course, we can use it with modern Windows 11 too. Once the drive is ready, the handoff to the operating system works exactly the same as with any other storage device. The BIOS loads the boot sector, which then loads bootmgr, the Windows bootloader. Windows doesn't care how the drive was initialized because moments later it loads its own native NVMe driver. From that point on, the BIOS and the INT13H interface are no longer used until the next reboots. With one exception. Apparently, Windows does care if the BIOS has native NVMe support during the Windows setup. So if we start installation from a USB drive, Windows Setup will detect the NVMe drive with its own driver, but it will refuse to continue because it thinks the drive isn't bootable. The solution is to deploy the installation files directly using DISM, the Deployment Image Servicing and Management tool. So we have to press Shift plus F10 to open the command prompt and type out the deployment command, which is pretty long. If there are no other partitions, the USB drive with the installation files should get letter D and the NVMe drive letter C. If not, you'll have to adjust the drive letters accordingly. The final step is to make the SSD bootable using the bcd boot command, then mark the partition as active with disk part. After the next restart, as long as the NVMe BIOS Option ROM is in place, Windows 11 boots right away. In the end, I really like that I can now boot from an NVMe SSD on pretty much any system I want. Just keep in mind that an Option ROM is a legacy BIOS thing. In pure UEFI, there is no INT13H, and the firmware never executes 16-bit BIOS Option ROMs. So if you have a UEFI motherboard without native NVMe boot support, like this Gigabyte H81 HD3 I have, and you still want to stay in UEFI mode, you'll need to inject an NVMe driver module into the firmware. It's about as complicated as it sounds, but it's absolutely doable. Alright, I hope you enjoyed this video. Stay tuned and don't forget to hit the subscribe button. Omores out.